Hi, my name is Emre Tatar, and I got two of my friends. One is Dengir, one is Yaman. We're gonna present you how we manufacture scooter right now. First, I would like to start with the abstract of our project. Scooters have become one of the most popular personal transportation vehicles in recent years. They are lightweight, portable, and environmentally friendly. In this project, we examined how a scooter is designed, which materials are used in its production, and which manufacturing processes are required to produce it. We also analyzed how material selection affects the durability, strength, and overall performance of the scooter. Now we're moving on to introduction part. As cities become more crowded, people need faster and more practical transportation methods. Scooters provide an efficient solution for short distance travel. They are easy to carry, require little storage space, and can be used by people of different age groups. Because of these advantages, scooters are widely used in urban areas, campuses, and recreational activities. Next, I want to show you how the technical drawings are. Next, let us define what a scooter is as we go back to introduction. A scooter is a lightweight vehicle that consists of a handlebar, a standing platform called a deck, wheels, and a steering mechanism. The rider stands on the deck and controls the direction using the handlebar. Some scooters are manually powered while others use electric motors. In our project, we focused mainly on the structure and manufacturing aspects of a modern scooter. The purpose of a scooter is to provide a convenient and efficient transportation option. Scooters help users travel short distances quickly while reducing traffic congestions. Compared with cars, they consume much less energy and have a smaller environmental impact. They are especially useful in crowded urban environments where traditional transportation methods may be slower or less practical. Now, let's talk about the usage of scooters. Scooters are commonly used for urban commuting and daily transportation. Many students use them to move around campus, while workers use them to travel between public transportation stations and their final destinations. This is known as last mile transportation. In addition, scooters are often used for leisure and recreational purposes. Shared scooter services are also becoming increasingly common in many cities around the world. This is technical drawings again. Fine. The first component is the handlebar, which allows the rider to control direction. The steering column connects the handlebar to the front wheel and transfers steering movement. The deck is in the platform where the rider stands. The front and rear wheels provide mobility and stability. The brake system ensures safety by allowing the rider to slow down or stop. Lastly, the folding mechanism makes the scooter portable and easier to store or carry. These components work together to create a safe, lightweight, and efficient transportation vehicles. Now, Lengir will continue with selected materials.
Now I will talk about the materials we selected for the scooter. When choosing materials, we consider three criteria: strength, weight, and cost. We used five main materials: aluminum alloy 6061 T6, carbon steel, polyurethane, rubber, and ABS plastic. Each one was selected based on the requirements of the component it is used for. Let me explain them one by one. The first material is aluminum alloy 6061 T6, the main structural material of the scooter. It is used in the deck, the handlebar, the steering column, and the main frame. We choose aluminum mainly for its excellent strength to weight ratio. It is much lighter than steel, but still strong enough to carry the rider safely. It also forms a natural oxide layer, so it doesn't rust. Very important for outdoor use, and it's easy to extrude, machine, and weld. The aluminum parts are produced in 5 steps. First, extrusion. Aluminum billets are forced through a die to create long profiles for the frame and deck. Second, these profiles are cut to size. Third, machining, drilling, and milling create the holes and connection points. Fourth, the components are welded together to form the frame. And finally, surface finishing, sanding, polishing, and anodizing, which thickens the oxide layer and improves both appearance and corrosion resistance. The second material is carbon steel. While aluminum forms in the main body, carbon steel is used in the highly loaded parts. Wheel axles, bolts, screws, the folding mechanism, and the brakes. These parts face the highest forces and constant friction, and carbon steel provides high strength, wear resistance, and load-bearing capacity. It's also very cheap, which makes it ideal for mass-produced small parts like bolts. Carbon steel parts are produced in 6 steps. It starts with bar rolling, producing steel bars with the required diameter. The bars are then cut into pieces and machined, turning, drilling, and threading for the bolts. The fourth step, heat treatment, is critical. Hardening and tempering greatly increase strength and wear resistance. Then a surface coating like zinc plating is applied. Because unlike aluminum, steels rust easily. Finally, the parts are assembled into the scooter. The third material is polyurethane, used for the front and rear wheels. PU is perfect for wheels because it combines 3 properties. High wear resistance, so the wheels last long. Shock absorption, which makes the ride comfortable and good traction. Strong grip on the road for safety. It's also much quieter than harder materials while rolling. The wheels are produced in 6 steps. First, the polyurethane resin and additives are mixed. Then the liquid PU is poured or injected into wheel molds. The third step is curing. The material is heated and hardened, which gives the wheels its final strength and elasticity. After finishing the surface, bearings are installed into the hub for smooth rotation. Finally, the wheels are mounted onto the carbon steel axles. The last material in my part is rubber, used in the parts that touch the rider, handlebar, grips, vibration damping pads, and protective covers. Rubber gives a soft, comfortable grip and has a high coefficient of friction, so the hands don't slip even in wet conditions. Its elasticity also absorbs road vibrations, reducing fatigue, and it keeps these properties in all weather conditions. That concludes my part. Now Yaman will continue with ABS plastic.
Uh, I will be presenting the final stage of our scooter manufacturing process, which includes plastic compound production, final assembly, surface finishing, and quality control. Looking at the slide 50, looking at slide 15, we selected ABS plastic for specific non-structural parts. Why ABS? Because it offer an excellent balance of lightweight properties and high impact resistance, making its perfect components prone to collision, such as well covers and fenders. On slide 16, you can see the production. You can see the production workflow. We start by drying the raw ABS pellet to remove moisture, followed by high precision injection molding. This process allows us to manufacture complex geometries quickly and efficiently for mass production. On the slide 17, this is the where all our individual components come together, assembly operation. In this phase, the aluminum frames, steel structural parts, and ABS plastic components are integrated. The process begins with the sub-assembly of the main chassis, followed by installing the wheels, motor, and braking system. The assembly of the handlebar and falling mechanism is particularly critical as it directly impacts user safety and probability. Ensuring every bolt is timed to exact torque specification is vital for the vessel's structural integer and product lifespan. On once the physical assembly is complete, we move to surface finishing as details on slide 18. This phase isn't just about aesthetic, it's about durability. We use mechanical polishing to remove machining marks and smooth out the aluminum part. Following that, inducing chemical NH2 oxide layer of the aluminum provide extremely corrosion resistance against harsh weather conditions. Final electrolytic powered coating or painting is applied to provide vibrant color and protect the plastic and steel part from UV degradation. The most critical phase of our entire production line is quality control, shown on this slide. These tests serve as the ultimate report card before the scooter leaves the factory. We perform dimensional audits using digital calipers and CMMs to gradate all tolerances are met. However, the most vital checks are the load test and brake test. We subject the frame to over 120 kilograms to ensure no structural deformation occurs, and we rigorously measure stopping distance on the both wet and dry surface because safety is our absolute priority. To last slide highlights the academic and industry reference that guided our engineering standards. We relate heavily on industry standards literature from Kalpakjian, Grover, and Ashby to select material and optimize our manufacturing progress.
Thank you for listening us. Goodbye.